Assalamualaikum warahmatullahi wabarakatuh, everyone. My name is Ahmad Aziman bin Azlan. I am from Group CS2305A. Today, I am excited to present to you my project proposal, CHILIGUARD, the Chili Disease and Pest Detection System. This project has been supervised by Tan Sri Dr. Jamaluddin Haji Jasmis. Here is an overview of the content we will cover in this presentation. Chapter 1, Introduction, Chapter 2, Literature Review, and Chapter 3, Methodology. Now we look at the background of study. Chili peppers are among the crucial plants farmed around the world, partly because of their food, medicine, and economic value. However, chili plants are exposed to a range of diseases and pest populations, which can lead to huge losses in yield and quality. Common diseases could harm chili plants, while pests threats to chili farming. Farmers must possess a good understanding of crop diseases, their distribution, and management techniques to effectively combat pests. Now, the challenge faced by farmers in nations with smaller incomes are particularly vulnerable to this issue. In addition to having fewer alternatives for control, tropical and subtropical regions of the world typically experience higher levels of disease and pest pressure, and issue project to worsen due the climate changes. Now we proceed to the next slide, which is problem statement. Current online detection system focus on plant in general, not specifically on chili-related issues. Traditional methods often require skilled staff, increasing labor costs, and causing resource inefficiencies. The current methods for identifying pests and diseases in chili peppers mainly rely on manual monitoring and visual observation. These methods are labor-intensive and prone to human error. Today methods are also time-consuming, leading to the spread of chili diseases and pests, which require early detection. Undetected plant disease can be costly for farmers and negatively impact state and national economies. Many farmers struggle to differentiate between common disease symptoms and plant viruses. Few are aware of the roles of pests like thrips and whiteflies are disease vectors, especially in India, Thailand, and Vietnam. The project has three main objectives: to design a system that automatically detects and clarifies disease and pests using machine learning, to develop the design system, and to evaluate the functionality and usability of the system. Now let's discuss the scope of the ChiliGuard project. The aim of this project is to provide a solution for chili farmers, agricultural extension agencies, and students in the field. We are developing a web-based platform that is accessible via desktop and mobile devices, and surely easy to use. Let's look at the design of the system. The web-based platform. The platform will be web-based, accessible on both desktop and mobile devices. It will feature a simple and user-friendly interface to ensure easy of use for all users. So we will apply machine learning techniques to detect diseases and pests in chili crops, enhancing the accuracy and efficiency to identify. The programming language for this project is Python, which will be used for data analysis and model deployment during the training phase. The data sets for training our model will be obtained from RoboFlow, Universe, and Kaggle, ensuring a diverse range of chili plant diseases and pests for comprehensive testing and evaluation. Let's focus on the implementation aspects of our system. The user interface is designed specifically for chili farmers and workers. It allows users to take image of chili plants and upload them to the website for analysis. The system will be provide real-time detection results, enabling users to receive immediate feedback. This allows for timely action and the implementation of effective management plans. Let's briefly explain the areas of study for this project. Chili disease cause significant damage to chili plants, resulting in lower crop yields and financial losses for farmers. There are 45 different types of virus that attack chili crops. The main pests of chili are pests, means thrips, and white flies. They have caused several economic losses to chili farmers when they affect the crops. The methodology used for the ChiliGuard project is the agile approach, which consists of five main phases: planning, analysis, design and development, testing, and documentation. In the planning phase, need to identify the problem statement, define the project objective, and establish the project scope. In the analyze phase, gather all necessary information about the project. This includes researching the problem, reviewing related words, and suggesting potential solutions. During the design and development phase, we design and develop the system algorithm and the solution to the problem. This includes creating the web-based platform and integrating machine learning techniques. In the testing phase, validate the result of the system to ensure it is working properly. This includes testing of the detection algorithms of user interface. Finally, in the documentation phase, we compile all the results and document the entire process for future reference and potential improvements. Now, let's look at the use case design and activity diagram for CHILIGUARD system. The user interaction with the system is straightforward. The user inserts an image of a chili plant and the system processes the image to provide the results. While the system workflow involves several steps. The first one is the system receives the image, and the second one it perform image segmentation, and then it will extract relevant features, and then it classifies the image based on the extract features. Finally, it detects and reports the results. So this is the activity diagram for the user and the system. Let's take a look at the process flowchart for the CHILIGUARD system. The user start by choosing between two methods, which is camera identification or gallery identification. If they prefer using a camera, proceed to the next step. If they want to select an image from the gallery, skip ahead. For camera identification, capture an image using the camera. The action here is take picture, Chilli and Pest. For gallery identification, select an image from the gallery. Select action is select image, Chilli and Pest. Both pass coverage at this point. The system process the image. The action here is click detect. The system refers to a knowledge database to analyze the image. The action here is knowledge database. Finally, the system displays identification results. The action is results. Let's explore the key elements for user interface. The first one is header, which is display the project name. The second one is menu bar, which is horizontal layout for any intuitive navigation. The third one is content area, central space for displaying dynamic content. The fourth one is camera identification, which is allow users to capture image with the camera button, take picture, chilies, and paste. The fifth one is gallery identification, enable selection of image from the device galleries. The button is select image, chili, and paste. Finally, the result display, real-time display of identification results. And then image will appear here. So this is the user interface after the process. Let's go into the design of the image processing technique, focusing on the CNN. The input image for the system is collected from the public dataset Kaggle. This project specifically focused on three types of chili leaf, healthy, disease, and affected by pests. Each category comprised 100 datasets, totally 300 pictures. To standardize the input for processing, all images were pre-processed by resizing them to 256 times 256 pixels. The CNN architecture is designed with 12 layers, which include convolution and pooling layers for feature extraction. These layers are crucial for identifying patterns and differentiate between healthy leaf, disease leaf, and those affected by pests. To ensure the robustness of the CNN model, we will split the data set into three parts: 80% for training, 10% for testing, and 10% for validation. During training, the CNN learns to extract features from the input images. This process enables to model to recognize characteristic of healthy leaf versus those affected by disease or pests. After training, the model undergoes testing and validation using spread portion of the dataset. This step ensures that the CNN can accurately classify chili leaf in real-world scenarios. Once trained and validated, the CNN model can make prediction on new unseen chili leaf image. This capability is essential for real-time detection and monitoring in agriculture settings. In summary, our user interface for CHILIGUARD is designed to be intuitive and effective, facilitating easy navigation and seamless interaction. Finally, we go to the hardware and software that will be used in the development. The laptop model is laptop Acer, which have 16 GB RAM. For the software, I will be use the operating system, Windows 10, Microsoft Visual Studio Code, And the programming tool will be Python, and for the journal citation is Mendeley. So that's all from me. Thank you for your attention.